Hey guys, so my computer's back. That's exciting. So we're gonna have classes like regular this week. Um, this week we're gonna be looking at just the three different forms of quadratics that we've been doing. So, anyway, I'm gonna go over what words. I'm gonna go over what the forms are, what they look like, and what the benefit of them is. So, if you remember, the first form that we looked at was vertex form, which is y equals a times x minus h squared plus k. So, the benefit of vertex form is, spoiler, that you can pull out the vertex. So, the vertex is hk. The main thing you have to remember is to flip the sign of the number that's in parentheses with x. So, vertex. There you go. We've been doing that for a while, so hopefully you guys are pretty cool with that. So with standard form, which is y equals ax squared plus bx plus c, it's called standard form because it's pretty standard. Like this is the normal way that you see a quadratic. But one thing you should know about it is very easy to find a y-intercept. We did learn how to find a vertex from standard form, but we're not really focusing on that right now. It's just kind of like what you can pull straight out of these, you know. So when you're looking for a y-intercept, what you do is you plug in 0 for x, and so that would just take away the a term, which is the quadratic term. It would take away b, which is the linear term, and just leave you with c. So the y-intercept is always the point 0, c. So that's one thing that you can just pull straight out of standard form. Sorry, this is my cat Moki. Probably see her in the background of class sometimes. Anyway, factored form, which sometimes can be called intercept form, looks like this. So minus r minus s. So as we talked about, it's not the time. As we talked about when we were going over factoring and factored form, this form is mainly used for finding x-intercepts because it's the quickest way to find an x-intercept of a quadratic. So in this case, the x-intercepts, and there sometimes might be just one x-intercept if r and s are the same number. But either way, the x-intercepts would be the points r0 and s0. And once again, you just kind of have to remember like it's x minus r. So you have to flip the sign of whatever's in the parentheses with x. That's going to be kind of a common thing that you're going to see with quadratics and polynomials and all sorts of stuff. So try and get that stuck in your brain. Okay, so the last thing I wanted to talk about is a. So if you'll notice, the one thing, I mean, other than having x's and y's in all of these forms, the other thing that they all have in common is that they all have a. And a always does the same thing, okay? It's forever the same, regardless of whatever form you're in. And the way it works, sorry, my brain is fried, is that, sorry, so what it does is it affects the shape of the parabola. So there's two ways that it can do that. It can do that by being positive or negative. So if a is positive, that means that your parabola is going to open up. Okay, it's going to be like a U. If it's negative, then A is causing a reflection, so it's going to be like a hill. Okay, so it's a reflection, which means that it opens down. Okay, the other thing is whether, like, the magnitude of A, essentially. So we're not really, the positive and negative is just opens up or opens down. Magnitude is like, how big of a number is it, right? So if it's a number between 0 and 1, and these bars are absolute value, they can also mean magnitude. It basically just means it doesn't matter if it's positive or negative. So take the positive or negative out of the equation. If it's between 0 and 1, which is usually a fraction, then that means that A is going to make your parabola wider. This is called a compression. Okay. There we go. So between 0 and 1, it makes it wider. The way I used to remember it when I was in high school was the fractions make it fatter, FF, that sort of thing. Now, if the magnitude of A is bigger than 1, okay, then it's going to be narrower, which is called a stretch. And one thing I should say is that the smaller the fraction, the more wide it will be, and the bigger the number, the more narrow it will be. So as the number gets bigger, the parabola gets more and more narrow, which hopefully you saw when we did the transformation stuff. But just something to think about. So anyway, those are the 3 forms, and that is A in a nutshell. So this week, the first half of the week is going to be pretty chill, and the second half of the week, we're just kind of going to review everything we've done with quadratics so far, just to make sure everybody's feeling good about it. So in this case, we're just going to kind of make sure that we can go through and, like, keep losing my words. we're gonna make sure that we can use the form properly. I don't know. What doesn't sound right? Find what we need to find the easy stuff from each form. Words. It's Sunday night, Anyway, so for this one, I didn't mean to leave the vertex in, but I did. So let's do it. So state the y-intercept of the vertex. That doesn't even make sense. State the y-intercept of the vertex. See, look at me. My brain is fried. That's supposed to sit. That's what the problem is. Of the quadratic. Typos, man. What are you going to do? Okay. So state the y-intercept of the quadratic. So in this case, you don't even have to do anything. You should just be able to look at that and say that the y-intercept is at negative 28, because as we set up here, the y-intercept is the point 0c. If you haven't written this down, rewind this video, pause it, write it down. It's good stuff. Okay, so the y-intercept is the point 0, negative 28. And I just know that right from looking at it, right? So it's my y-intercept. Now, when it says describe the shape, that has to do with A, which is the number in front. So it's negative and it's a 2. So this parabola is going to be opening up. No, it's not. It's going to be opening down or reflected. And there's lots of ways you could say that, guys. As long as you sound like you know what you're talking about, I'm cool. And it's going to be narrow, or that extra E in there for, or stretched. Okay, so it opens down or is reflected, and it's more narrow, which is a stretch. So, okay. Um, here we go. Vertex form. Cool. So state the vertex of the quadratic. Once again, this should be easy. Just flip the sign of the number inside the parentheses with x. The other set stays the same, so it becomes +4, -4, right? That goes there, that goes there. Just don't forget to flip the sign on the first one, okay? So that's my vertex. Man, my handwriting's ugly tonight. That looks like vertex. Sorry. Okay. Now as far as the shape, it's positive, so we're going to say that it opens up. And it's wide or stretched or compressed. Oh, it's like we're in school for real and my brain's like legit fried from a long day at work. Lucky you guys. Okay. Anyway, so opens up and it's wider or compressed. Like I said, it does not matter which words you use. I'll know if it's right. You can use different words to say it. I just need it to be correct, if that makes sense. Okay. So, excuse me. Last one. State the x-intercepts of the quadratic and describe the shape of the quadratic. See, look at me using the right words and everything. Good job. Okay. So the x-intercept. Now, just remember that the x-intercepts, what we're doing is we're still saying setting each factor equal to 0 because of something called the zero product property. So that when we plug in 0 for y, which is how we find an x-intercept, when we have two things multiplied together to equal 0, the zero product property states that either one or both of those things must equal 0, because the only way to get 0 when multiplying is to multiply something by 0. It could be anything by 0, but one of them has to be 0. So essentially, I'm just setting each factor equal to 0. So essentially what that means is I just have to flip the sign. So this becomes -4. And this becomes 6. But remember that intercepts are points. They're not numbers. So if you do that, you're not doing it right. I mean, you're doing it right, but you're not finished or you're not correct. So the x-intercept, x-intercepts are the points -4, 0, and the point 6, 0. Okay. When it talks about describing the shape of the quadratic, again, that's talking about A. So it's negative, so that's going to open down or be a reflection. And it's 3, so it's going to be narrow or a stretch. Now, if there's ever one where it is asking you to describe the shape of the parabola and A is just 1 or a -1, you can say opens up, opens down, whatever, but you could just say it's like a standard size. It's the standard size of a parabola, or the width, narrowness doesn't change, or however you want to say it. But anyway, okay, so that's this comparing forms stuff in a nutshell. I keep saying that. Oh.